Today we will discuss about loan eligibility prediction in banks. So for this I have taken a data set from Kaggle, which is a loan eligibility predictor. So I'm gonna load the data set now. Okay, so this is the data set we have. So imagine you're going to an application to avail a loan and they are giving you a form. So in that, the basic details that you will fill are gender, whether you are married and you have dependents, education, self-employed, applicant income, co-applicant income, whether if you are taking loan with your wife or your brother, whatever it may be, and the total loan amount and the loan amount term. Loan amount term something is like the total accumulated, the total amount which you will pay for over the period of 15 years or 20 years as an EMI. Let's say like you have an $100 as an loan amount, but you will be repaying as a 360, which means for the period of 20 years, and you will be splitting EMI, right? So that the total amount is 360. And the credit history, obviously when you have a CIBIL score, and they will show what is the credit history for that, and if you have any property submitted, and I'm sorry, the property area from where you are availing the loan for a house loan, whether the property is in rural, urban or semi-urban, and you have that training loan status, whether it has been approved or not. So this is the sample data that we're going to use today. Okay, so here we will do some analysis on the data. So for that we will fetch the categorical features and the numerical features. So categorical features equal to I for I in object type equal to O. Okay, so here that loan ID is an identifier, and the loan status is our final dependent variable, so we have to remove that from our list. So loan ID okay, so the total categorical features one, two, three, four, five, six. Okay, similar way we can find the number of continuous variables, the features. Okay, for I in df dot columns of df of I not equal to O. Okay, here I have to give df dot d type not equal to object. So these are all, so total 6 plus 1, 2, 3, 4, 5. Okay, so first we will do some exploratory data analysis for the categorical features. So for that we can use count plot from Seaborn. So for that, what we have to use, we will plot it fig dot plt dot three comma 2 1 3 comma, because we have 6 features, so we will plot 3 rows and 2 columns. Fig size equal to 15 comma 15. So this will return a flat and 1D array for I, comma, feature in enumerate of features SNS dot count plot of, here our axis should be the feature, and hue is like the final one, the loan status for whom we were comparing against, and we have to fill these details. Data equal to df, and we will run this now. Okay, so these are all the plots we have obtained. Okay, so what is the insight we are getting from this? Okay, of all that, the total number of more number of loans got approved for male candidates. That is inference that we are the first graph. Similarly, when compared to male and female, when compared to married or unmarried, see, married has more chance of getting the loan approved. So same way, if you go to the dependents, like if you have 0 dependents, then it's like high chance of your loans is getting approved. And obviously, if you are graduated, non-graduated, graduates get more chance of loan approval. And the same goes for employed. And if you are self-employed, which means it's a very less likely. Self-employed means like if you are into business or something, there is no guarantee of getting the monthly income, right? There is no stable income. So the most, the preference is gone to people who are salaried, monthly salaried. And the property area, that remains the same. There is no significant difference there. Say for rural, urban or semi-urban, it almost the same. Semi-urban gets the highest chance, but it's like more or less on the same. So these are all the inferences or insights or observations, you can say observations, we got from the categorical features. Same way, now we will plot for the numerical features. Okay, no, I can copy the same. So here, instead of category features, none, numerical features, feature and loan status, and okay, let's execute this. Okay, now we have to give, instead of count plot, we have to go for KD plot. See, count plot is for only for this categorical features or discrete features, whereas whereas this KD plot is for that kernel density estimate. This is for continuous range, continuous features. Okay, let me execute this. Okay, we got, I will add one more, fill equal to true. Okay, so this is the inference. Okay, from these graphs what we infer is like obviously more number of loans got approved when the applicant's income is concentrated or between in the range of if it is 10,000, I can say is a 10,000 like around 5,000. So when your income is around 5,000 and more number of applicants income is in around 5,000, and the same case goes for co-applicants income as well. And the loan amount that got approved, it ranges from around $100 to $2,000. Yeah, 100 to 200. That is at the density. So approved loan amount was 100 to 200. And the same way that that approved loan amount term that stands around 350 to 380 something, somewhere 382 or 352. This is obviously when the credit score is high, you will get more chances of approval. So this is fine. So what we infer, what is insight we got from is like when the loan amount is around $100 to $200, there's a more chance of your loan getting approved. And the loan amount term depends upon like how many years you're putting. Let's say like you're applying the loan amount term just for 5 years. The bank is not going to approve. Less chance of approval because the bank won't get any interest as a revenue from the side. So let's say you're putting for 20 years or something. So 20 years in the sense like you will pay interest for all those 20 years. So that's the reason it ranges from 300 to 400. So it's like more or less on the 360 loan amount term. Okay. And similarly, we can, this is with respect to that of our loan status. We can also get some insight based upon that continuous features. So what I'm trying to say is like, so this is like against your continuous feature against our loan status. We can also plot like this to see if there is any similarities or any meaningful insight we can get from your features. What I'm trying to say is like categorical features, and we can also plot the KD plot, but instead of feature, we will plot here. And instead of the feature, we can go with applicant income. Applicant income. So we can also plot against like this, what is applicant income with respect to when he's a male or female, when he's a married or non-married. So these kind of beautiful insights we can obtain from our KD plots. It's not only for applicant income, we can change it to different insights as well. Like now I'm going for the loan amount. Okay, now see the loan amount with respect to male and female. So for the male, the loan amount always stands from around 0 to 200. Okay, major number of more males, and their loan amount stands at 100 to 200, and self-employed or employed. See, so these are all the insights we can obtain. So based upon these plots, we can write you can write our observation. Like from each of these plots, we can write our observation, and we can plot it, and we can write a conclusion. Okay, from these features, these are all the things what we have obtained, and we will continue with that, handling the categorical features and other things in our next video.